All right, so we are in Algebra. We are on our brand new unit 15-1. So all of unit 15 is, again, 5 days. Unit 15 is all about factoring. Let me open up this is Algebra 2. This is Algebra 1. Here it is. Our unit, which is up online for you to fill in if you want. I'm not super checking off if you're checking the percents because it's not a Khan Academy unit. Next unit, unit 16, which is going to look like this, if it opens up. Is going to be a Khan Academy assignment, and I will want you to be filling in the percents over here. But for this Unit 15, it is 5 lessons, and one of those lessons is just a whole day on a practice test. So we'll have a ton of review. If it feels like we're going really fast, it's because we are going fast. We need to get through basically a month's worth of material in a week. So I'm condensing it all down. I'm simplifying it into 2 steps. There are 2 steps whenever you factor. This will be in the notes, but step 1 is today. Step 2, there's a lot that I can talk about, so it's 2 days worth of step 2. Every polynomial that you will see in Algebra 1 is always 2 steps. In Algebra 2, we're going to add a 3rd step on there as well, factoring by grouping. But for now, there are 2 steps. Ask me questions. All right, so we're back here on the notes. What does it mean to distribute? Can someone give me an example where you would distribute with a quiet raised hand with your card, because everyone has their card? Give me an example where you would distribute. Can you give me a problem? Maybe from Unit 14, you can even look back at a homework problem. Where was a time where you distributed? Yeah, go for it, Andres.
So you could put a 3 on the outside,
Okay.
and then parentheses, 4x plus 2.
Yeah, sure. And then you would distribute, so you do the 3 times 4x and you get what?
12x.
12x, and then you do the 3 times the 2 and you get?
Plus 6.
Plus 6. That was an amazing example. Perfect. Thank you. And that's exactly how I do. I just kind of randomly choose numbers, make sure that you don't have the same like term on the inside, and that so both 4x and 2 are not like terms, and then you distribute. Go ahead and write down Andres' example. That was a great example. So let me come back here and give Andres some XP. That is Algebra 1, or that was Algebra 2. We are in Algebra 1, and Andres got XP. All right. So factoring. That is what we're talking about today. How does that compare to distribution? I'm going to use Andres' example, 12x plus 6. 12x plus 6. So now I'm going backwards. I'm going backwards from distribution. That's all I mean when I factor. How do I undo the multiplication? So 12x plus 6 turns into, well, now I have to use the greatest common factor. That's why we had that warm-up. What is the greatest common factor of 12 and 6, or 12x and 6? And it would be 3. And then what's left over, if I divide each of these terms by 3, and if you're not picking this up on this first pass, we have 7 different passes going through factoring. So the greatest common factor is 3. I pull that out. I divide 12x by 3, and that is now 4x. I divide 6 by 3, and I get 2, a positive 2. The main thing to take away here is it's backwards distribution. I want to write that down. We're down here as well. Backwards distribute. All we're doing is going backwards today. This whole unit is going backwards with Unit 14. So if you haven't really understood Unit 14, and most of you understand it pretty well, the average on the test was an A. All we're doing is going backwards now. All right, so the greatest common factor, I need a quiet raised hand. It's the what factor that does what to both numbers. I'm looking for a size word right here, and I'm looking for an operation like adding or subtracting or something like that in this spot. Anyone want to take a stab? I need both of these. Andres has his hand, but I want to call on someone new if possible. He's our backup. Anyone want to take a guess? It's the what factor. We already found the greatest common factor in our warm-up too, so use our knowledge. Anyone want to take a guess aside from Andres? All right, Andres, you're up.
The greatest factor that multiplies both of them?
Ooh, you're really, really close. So it is the greatest. I'm going to use the word biggest instead of greatest, if that's okay with you.
That divides.
Yeah, it is divides. So it's the biggest. And I know that a lot of people use the word greatest, but when I think of great, I think of like Alexander the Great, I guess. He was a great person. So I think biggest is a better word because it's a size number. Greatest is supposed to be a size number, but I like the word biggest. Biggest common factor. So it's the biggest factor that, and as Andres says, divides. both number. And I'm going to be coming back to this definition over and over. So take 10 seconds to digest this definition. The biggest factor that you can divide both numbers from. I'm going to be asking you questions like, well, can I divide by this? Can I divide by this? I'll keep getting bigger and bigger until I can no longer divide. So you're taking time, you're digesting that definition, really understanding it. All right. So I said already when we were talking about our unit guide that all of our factoring that we're ever going to be doing in Algebra 1 is always 2 steps. We are doing step 1 today. So circle step 1. This is what we're doing today. We're doing step 2 tomorrow and on Monday when we get back. But we're doing just step 1 today. And step 1 is the greatest common factor. So write down GCF. GCF, greatest common factor. We like acronyms. If you don't think you're going to remember what GCF stands for, then maybe you want to write out greatest common factor, but I like being lazy in my notes. All you have to do is always check greatest common factor, and this might not happen. So we'll put a maybe here. Maybe there won't be a common factor. I will be giving you an example today in our notes where you can't find a greatest common factor. All right, and then step 2, which we're learning tomorrow, is using the ninja star. We can all be ninjas in here. Ninja star. While some teachers might teach you, okay, this is a difference of squares, this is a sum of squares, advanced stuff like that, all of those things can all be solved with the same tool, the same ninja star tool. I will be defining things, but mainly GCF, ninja star, over and over. That's this entire unit, not our heads. That's the entire unit, 2 steps. I can repeat those 2 steps, Mr. Snell. I got this. Okay. Coefficient. So we're finding the GCF now of a polynomial. Today in our warm-up, we're doing these, just numbers. Now we're going to apply that to polynomials. So you have 2 steps whenever you're doing a GCF of a polynomial. So now we're inside step 1. You first have to do the coefficient, and that's just a GCF. I mean, that's straightforward. So we'll just write GCF of a number. That's easy. That's like the warm-up, just finding the GCF of those numbers. That's the number out in front, the coefficient. We know how to do that. We saw how to do that on the warm-up. The tricky bit now is adding on the fact that you now need to find the GCF of the variable as well. So you can take a peek at example 1. I have a variable and a variable along with a coefficient and a coefficient. So there are 2 steps to doing these problems. So the variable, again, I'm coming back to this definition of what can I divide by? If I have x to the power of 7, can I divide by x to the power of 2? I nod my head. Yes, I can divide by x to the power of 2. Can I divide by x to the power of 3? Yes, I can still do that. I can go all the way up to 7, but I can't divide by 8 anymore. That will turn it into a fraction. So that is a long-winded way of doing this. Write this down. We had this rule from, oh gosh, was it unit 12? I don't even remember the unit. But this rule that said x to the a divided by x to the b. Can someone remember what this rule says? It's x to the power of something. Who remembers this rule? Jose remembers this rule. Who else remembers? Fernando, Andres, Josie halfway, no, rubbing the forehead. Sergio, Cohen. I'm going to give it to Jose. What is this equal to?
X to the power of a minus b.
There it is, a minus b. Thank you, Jose. Oh, let's come back here. What this is saying is, what is the number b, or I'm always searching for b, so can we put b in a box here? This b is the number that we're searching for. What is the biggest? Again, I'm coming back to this biggest definition. What is the biggest value that can be divided? Well, since dividing means I'm looking at the powers, as Jose said, I'm really looking for the biggest number that doesn't leave this with a negative. So I'm going to come back here and fill in my definition after I do example 1. Let's look at example 1. Can someone help me find the GCF, the greatest common factor, of the coefficients of these 2 terms? So first you have to remember, what is a coefficient again? And then what is the greatest common factor of those coefficients? I see 1 hand. I see 2 hands. I see 3 hands. I see 4 hands. Those same 4 hands that were raised, Andres, Jose, Sergio, and Fernando, and Cohen now, that 5th hand. Fernando, help us out. First of all, what is the coefficient? The number out front, right?
Yeah.
Okay, yeah. And then what is the the greatest common factor of 8 and 4? 4. All right, everyone write it down. 4 is half of the answer. Bless you. 4 is half the answer because we only did step 1. Now we need to do step 2. I need to figure out the biggest possible power, the biggest thing that I can find that can divide this x to the power of 4. It's going to be x to the power of something. Question is, what is that something? What is this power up here? I'm looking for the biggest possible power that I can. But if I choose 6 and I do 4 minus 6, that will be a negative 2. So I can't choose 6. I have to choose the biggest possible power. What is that? What is the biggest possible power that can divide both x to the 4 and x to the 6? I see one hand. I see two hands. Take a guess. It's a number. What's the number? I see Jenny and Monse just urging to do it. Cohen, go for it. 2 is a good guess. It's not quite right because I can do a number bigger than 2. Let's analyze what happens when we do Cohen's example. So if I did x to the power of 2, so I'm dividing by x to the power of 2, I'm left with x to the power of 2. Divide by x to the power of 2, I'm left with x to the power of 4 because I subtract. I can get rid of even more. I still have a 2 left over. I want to be left with nothing. I want to be left with to the power of 0. Do you want to try again, Cohen? Or do you want to give it to someone else? There it is. To the power of 4. Here is the answer. Write it down. That is our final answer. Box it if you want. I don't really need to box it since it's the only work. But it's to the power of 4 because 4 is the biggest possible number I can subtract from both of these things without going negative. So I'm going to come back up here now to my definition of what I should be doing with a variable. Whenever I'm dealing with a variable, look for the smallest exponent, or smallest power if you like that word better. The smallest exponent for these two terms was 4. So my answer was going to be 4. If I had a constant, like plus 1, this doesn't have any variable, so the smallest thing I can do is nothing. There is nothing that I can do with 3 of these. We'll see that example in a sec. I'm just going to repeat the same thing over and over. I need someone to help me with example 2. I need someone to do at least step 1. I want to do someone to do this step 1 right here. Who can help me with example 2? I see 1 hand, 2 hand, 3 hand, 4 hand, 5 hand. Who has their card still? Sergio, go for it.
So the coefficients first?
Yes, coefficient is first.
The greatest common factor is 9?
It is 9. Perfect. Yeah, thank you. So the coefficient between 36 and 9, the greatest common factor of those coefficients is 9. Thank you, Sergio. Oh, sorry. All right, I need someone to help me out now with step 2. I need someone to find the smallest exponent for the variable and tell me what to write. I see 1 hand, 2 hands, 3 hands. Josie? Yeah, go for it, Josie.
9y to the power of 8.
9y to the power of 8. You're correct. That's a full answer. Good job. Yep. 9y to the power of 8. Everyone write it. Josie saw that the smallest exponent was 8, and she just wrote y to the power of 8. It's that simple. I'm trying to make it as easy as possible for you guys. That's how easy it is. And you can box it if you want. You don't have to since it's the only work. If you had a bunch of work and then an answer, that's really when I want you to box it. But let's just get into the habit. Okay, so again, let's come here and see the difference between distributing and factoring. So going back to our old knowledge for distributing, can someone help me distribute this 3x squared into the 4x cubed plus 2? Who can distribute this for me? I want some answer right here. Quiet raised hand. Who can do this? Everyone should be raising their hand. Everyone did really good on your test. Same hands over and over again. Jose?
So 12x to the fifth
Yep.
plus 6x to the 2.
There it is. Yeah, thank you, Jose. Everyone write it down. That is our answer. That is how you distribute with a polynomial. All right. I need another volunteer to tell me what did I do with these coefficients, or sorry, that's not a coefficient. What did I do with the coefficients what operation? Did I add, subtract, multiply, divide, square root? What did I do with the coefficients? And what did I do with the exponents when I was distributing? Sergio.
You multiply them.
Yes, I multiply. Multiply the coefficients. And I'll wait for you to finish copying that down. And I'm going to come back to you, Sergio. I'm going to ask you, what did I do with the exponents?
You add them.
I added them. Thank you. Sergio got his 50 XP. All right. Now I need to factor. I'm going to factor out the greatest common factoring. But before I do that, I want to come down here and talk about what I'm doing with the coefficients and what I'm doing with the exponents. If this is the opposite, remember, distributing and factoring, those are opposites. I'm going backwards. This is backwards. If it's backwards, what should I be doing with the coefficients? Quiet raised hand. Go backwards from multiply, the inverse operation of multiply. Andres.
Divide.
Divide. And what am I going to do with the exponents?
Subtract.
There it is. Thank you, Andres. So first you need to ask yourself, what is the greatest common factor of 12x to the power of 5 and 6x to the power of 2? So this work that we just did here in example 1 and in example 2, I need to do that for these two numbers that are being added to each other. So I need one volunteer. Tell me what the greatest common factor is between 12x to the power of 5 and 6x to the power of 2. Remember, there are two parts whenever I'm doing greatest common factor. Coefficients and the variable. I see two hands. I want to see more hands, more hands, more hands. Preferably more hands with cards, but I still like the number of hands. I have 5 hands so far. Those same 5 are power 5. No more hands? Eder, Jessica, Julian, Montse, Jenny. I haven't heard from you guys yet. Your cards are still out. All right, I'll go back to Josie again. What is the greatest common factor? Say again? Yeah, so you're going to divide the coefficients after we find the greatest common factor. I'm just looking for what the greatest common factor is between 12x to the power of 5 and 6x to the power of 2. So 12 and 6, greatest common factor is, yep. And then what about for the exponents? X to the power of, ooh, careful, smallest, 2. There it is. Thank you, Josie. All right, Josie has found the greatest common factor, which is the first step now. I found the greatest common factor, and I factor that out. So this is going to go on the outside. Just like this 3x squared is on the outside, now I have to figure out what is on the inside after I divide everything. And I guess I'm subtracting the exponents. So I now need to divide by this greatest common factor. This 12x to the power of 5, look at this 12, look at this 6. I'm going to divide them. I'm going to divide the coefficients. Who can help me with this first term right here? I need to divide the coefficients and subtract the exponents. Fernando.
2x to the power of 3.
3. Yes, talk about why that's the answer.
Because 6 divided by 12 is 2, and 2 or 5 minus 2 is 2.
Exactly. Dividing 12, so 12 divided by 6, and then subtracting the exponent, so 5 minus 2 is 3. Perfect. Thank you, Fernando. I won't forget you this time. And I need someone to do the next exponent, the next term. So there's a plus sign here. There's also a plus sign here. Unless I factored out a negative, which can happen. All right, who's got this for me? I see Cohen's hand. Who else has it? I'm going to divide the coefficients by this greatest common factor. I'm going to subtract the exponents by the greatest common factor. Sergio.
Just x.
Is it just x?
6 divided by 6.
So 6 divided by 6 is?
1.
1. And then x squared divided by x squared is?
1.
1. So 1 times 1 is just 1. There it is. 1. Yeah, thank you, Sergio. 2x cubed plus 1. There it is. Sergio. Boom. That is the answer. Go through this problem one more time in your heads. I'm going to give you 10 seconds. Digest what just happened. All right. As a review, First, we found the greatest common factor of these two terms. There might be the greatest common factor of three terms. After we found the greatest common factor, we divide the coefficients by the greatest common factor and subtract the exponents for the greatest common factor and write that on the inside as the same number of terms. We're going to do this over and over again. Here we go. We're going to get faster and faster. We're going to get this better and better. All right. I'm not even going to tell you the steps because you have the steps in your notes. Someone help me out. Do the first step for me. Jose, go for it.
2. The greatest common factor would be 2.
Yep, the greatest common factor is 2.
8 to the 4th.
8 to the 4th. Perfect. Jose just did the first step for us. Thank you, Jose. He found the greatest common factor of both of these two terms. 6 and 8, the greatest common factor, 2. 8 to the 4th, 8 to the 7th, the greatest common factor, 8 to the 4th. You're choosing the smallest exponent. Okay, I'm going to set up the parentheses for you. So there's a parenthesis here and a parenthesis here. If there were two terms here, there will be two terms inside here. I need one volunteer for the first term, one volunteer for the second term. Who can do the first term? Same hands over and over again. Cohen, go for it.
3, a to the just 3.
Yes, because it would have been a to the 0. And anything to the 0 is 1. Yeah, so it's just 3. Perfect, Cohen. I like your analysis. Good analysis. So 3, that was the first term. Who can do the second term? Yeah, Monse. There it is, 4a to the power of 3. 8 divided by 2 is 4, that's the coefficient. A to the 7th, I'm going to subtract 7 minus 4, and that's 3. Good job, Monse. Done. That's the final answer. Don't have to do anything else. Next one, example 4. I have to factor using the greatest common factor. I have a, ooh, these are huge numbers. It's scary, but it's the same procedure. You guys got this. Step 1, I need 3 volunteers. I have 3 different things to write. 3 volunteers. Jose's ready to go. Fernando's ready to go. What is the greatest common factor of both of those two terms? Oops, I kind of gave away what you're supposed to be doing, but there it is. Fernando, go for it.
5.
5.
B.
There it is, b to the 100. And I'll set up the parentheses for us. Note that Mr. Sindel is going to do the sign for you as well. This will trick us, but if this is a negative, copy the negative. Copy the negative in here. All right, so Fernando just got his, that was the wrong amount of XP. Let me just randomly give you the rest of it. There it is. Fernando found the greatest common factor. I need to now find what is left when I divide by that greatest common factor. I see one hand. Two hands. 3 hands. Sergio, go for it.
7. B. To the second power.
There it is, 7b to the second power. Thank you, Sergio. 7b to the second power, 7b squared. Either way is fine. And last but definitely not least, Cohen.
4.
4. Just 4? It is just 4. There it is, 7b squared minus 4. 100 minus 100 means there's nothing left, and it's just that 4. Ooh, okay. We have a tricky guy. 3 terms. Can you do it? Oh my God, there's 2 people already ready to do the first step. I'm going to give you more time to think. A question, yes.
So we're in the example 3.
Yes.
Yeah. I mean example 4. Wouldn't it be a negative? Oh wait, never mind.
Yeah, so yeah, just make, other people might have this question, not just Andreas. So it is a negative 4, this is a negative 20, so you can either immediately copy the sign, or you can factor this as negative 20 divided by 5. Either way works. Yeah, good catch. All right, still having time to think, What is the greatest common factor of all 3 of these things? Oh, yeah, Jessica. 10. Yep, that's the first half. C to the power of 32. Beautiful. There it is. 10 was the greatest common factor of all of these things, all of the coefficients, and then 32 was the smallest exponent. Question, are you ready for the next one?
Oh, no, wouldn't the greatest common factor be 20?
20 doesn't go quite into 30, though.
Oh, shit.
Yeah. No, it is tricky, and until we get lots of practice, we're going to keep making those mistakes. Those are good. You just learn right now. Thank you, Fernando. All right, Jessica, I have your card now. Mwahaha, I've collected you. Okay, so there were 3 terms here, which means when I set up my parentheses, there should again be 3 of these slots. The first is separated by a plus, and then a minus. I'm just copying the signs so I can't make that mistake. All right, I need 3 volunteers. Who's it going to be? Andres is going to do the first one.
So it's going to be 3c to the second power?
Beautiful, yes. 3c to the second power. Thank you, Andres. Gunnar, yes.
6c to the power of what?
6c to the power of 1, and I can just leave it as 6c. You can do either way. Both are correct. Thank you, Gunnar. And I have your card now, Gunnar. And finally, Cohen. 10, just 10? I've called on you for just the single numbers for a few times now. Yes, you are correct, Cohen. Cohen is our master of getting rid of all of the variables. That is the final answer. That's it. Done. Whew, all right. Oh, only 2 terms this time. I want you guys to find the greatest common factor of number 6. 3x squared minus 5. What is it? Quiet, raise hand. 2 people, 3 people. Sergio, go for it.
5.
Ooh, 5 doesn't go into 3, though. Fernando? You're right. It is 1. And if it's just 1, you can't do anything. This one is done. Can't do anything. This one does not have a GCF. No GCF. I promised you before in this lesson, sometimes you don't have a GCF. This is one of those times. Because 3 and 5, their common factor is 1. You can't do anything there. X squared and 5 times 1, that's 0. I don't have anything to do for the variable. I don't have anything to do for the number. I'm done. I can't do anything. Done. For the homework, I'm not going to be mean like this, but for the test, I will be. So just know, sometimes there aren't GCFs. Ask me questions now. Give me a fist of 5. How well did you follow this lesson? Ooh, I get some 5s, a 4, 5, 4, 5, 4, 4. Okay, nice. Thank you. Go ahead and write your summary. If you write anything today in your summary, it should be this star. If you want to add extra, it should be this star. This second star, finding the GCF, this is the most important thing that we did today. Question?
What about like times GCF?
Okay, yeah, that works.